Yo, what's up, everybody? Welcome back. Today we are writing an XML parser. So context here is we've come across this a couple times in recent projects where sometimes we have some XML for some data that we want to parse, right? And so what we've done in the past is we've pulled in this library libexpat and used it to do the parsing that we gotta do. But I don't really like its API. So I think it would be kind of fun for us to roll our own. One, I don't think that XML parsing is too complicated. And two, it's kind of fun. And three, I need a little bit of a break from the GPU stuff. And this is kind of just like a free little win for us. So what don't I like? What don't I like about libexpat? So libexpat's pretty great in that it's a like streaming XML parser. So if we parse this Wayland protocol definition, what it will do is it'll say like, hey, here's a protocol block. Hey, we are starting a copyright block, and here's the content of the whatever block you're in. And like, oh, we're gonna end a copyright block. Now we're starting an interface block. So instead of trying to like parse like a full tree and give you like a tree abstraction, it gives you like events of stuff that happens. And I like that. I like that because it means that we don't have to trust the library implementation to track all the state of everything that we want to talk about. It just like kind of like gives us stuff as it comes, and we're expected to track that state ourselves. That's pretty cool. And I like that concept. What I don't like so much is that it uses like a callback based API. So when you use this thing, you call the parser. Eventually, you call this like XML parse function. And what it will do is every time it sees an event, it will call whatever you gave in like element handler. So we'll say things like, oh, start element. And it will call this. And so we've like implemented this thing that essentially wraps this into like Zig types or whatever. But I don't really like that. I think longtime viewers of my stream will see that will have heard that I'm really into like iterator based APIs now. I like the idea of control flow being like externally managed, right? So instead of us going like, hey, could you parse this thing and tell us when stuff happens? I would instead like to say, hey, tell me the next thing that's going to happen and call that in a loop, because then I can choose externally to do extra stuff or less stuff with that. And I can choose to like end early, and I don't have to like worry about like internals of how they handle returns of my callbacks. I can just be like, give me the next thing and I'll do something with it. So that's what I wanted to explore today. I think that we will probably target trying to get these Wayland protocol definitions working. So we have this like code generator for our Wayland client that we wrote recently. The idea here is that Wayland is like a protocol, and it has like interfaces, right? And these interfaces have like requests you can send, right? And so like these requests have like a known format, and so what we do is we like generate this code for these. Let's see if I can find that. It'll probably be in like this, right? So here is a WL display struct that we generate, and we have a function sync that takes some sync params, right? So we're basically generating this out of this, which says like, hey, I have a display interface, and I have a sync thing, and here is my parameters, right? So we should be able to walk this pretty simply. The plan is to kind of just like walk this thing, try to pull out like the important attributes here, like the name, the type, interface, right? We need all this stuff. Then it would be kind of cool to see if we can like implement, replace the libexpat thing in our Wayland parser with our implementation. And then if we get through all that quickly, we can try to like yoink some XML conformance tests and try to rip through them. But I doubt we're going to be conformant, and I doubt we will get that far. So like we'll see. I think step one here is probably to create some sort of like playground to play in. So I think we can still keep working in this Wayland client repo. I think that that's reasonable. And so I think that what we'll do is we'll just add like a new executable here to play with. So we'll do like source XML, like custom XML parsers or something. I don't know. And it will add this to our build, and we'll say like, hey, could we have some XML parser, custom XML parser, comes from is named custom XML parser, and he comes from custom XML parser. Like, wow, look at us go. And then I guess we will just say, hey, could you install that artifact, please? i.e., put it in the build directory. So let's start there. We'll see what happens. Hey man, I'm also making a small GPU thing on FPGA. Here's some tests. I'm willing to click that link. I guess I should click it off screen just in case it's like porn, because you never know what Twitter is gonna give you. That's pretty fucking sick, dude. That's super sick. Congrats. I hope to get there sometime. That's pretty cool. Pretty cool. Look at that. Look at that. Okay. All right. I guess we need a main function. Pub function main, and we will std debug print hello world. And I guess that means we need standard library. Wow. Import std. Boom. All right. I guess we need to run it to make sure it does what I expect. Okay, we get a little hello world. Now, I guess we are probably going to want to like pass in an XML file to parse, probably. So we'll say path is std process args alloc. I think you need to allocate technically on Windows, even though we're not on Windows. Technically, you kind of do, which means we need a general purpose allocator. Which must have default parameters, and we defer d into that thing. And then we get our allocator out of this thing. So this is like the generic interface for our concrete implementation. And now we have a args thing, and we could say const process name is equal to args next. This probably needs to be retried because it's allocates. Yep, and then. Oh, this isn't an args iterator. This is just the arguments. So we can just skip this. We can say args if args len is less than 2, we have a problem. We'll say std log error. Please missing file argument solid, and return error no XML. And then we will just say const path is equal to args1. Wow, look at us go. And now we will print the path to prove that we got it. Seems reasonable to me. Zig build and zig out. Bin custom parser. So he's mad because first of all, we forgot to free. Okay, so let's do that. And then also he's mad because we need args free. I forgot. He's mad because this thing probably needs to take the args as well, of course. I tried out dev containers in VS Code today. Didn't expect that I will have to understand all the inner workings of it in order to have it compile and create files with my unit. Yeah, that shit's kind of painful. Docker's like kind of nice in some way, but really annoying in a lot of other ways. We'll never use like garbage again. I mean, if you work with other people, it's pretty nice. I don't know if there's like a better alternative. Man, you never stop grinding. I mean, this is kind of a break. We're taking a break from the GPU stuff to do this. Today's break day. Okay, so he's mad because we didn't pass him argument, so let's pass him an argument. We'll use the Wayland spec as our example. Wow, look at that. He prints out where's Wayland, so we're chilling. Big chilling. Okay, so let's open the file. So it's current working directory relative, so let's open this thing. With probably I don't give a fuck arguments. It seems reasonable. And how do we want to do this? We probably want to like buffered read this thing. Right? Probably because that's faster typically. Which means we probably want like a reader. Yeah. And does this have like extra parameters? Nope. Okay. We'll call this a buff reader. And then I think that we probably want to pull out like the generic read interface from the buff reader. So I think you go like this. Reader, like this. Which means that now we should be able to use this as the input to whatever XML parser we write. Okay, so what is this? This is an IO reader. Self error read. Sure, okay. So I guess we will kind of make our XML parser. It kind of feels more like Elixir, to be honest. Kind of. So I'm going to call it that for now, and we'll come back to it later. Okay. So I guess this is not a struct. This is going to be a function. Because the type of this thing is going to depend on the type of our reader, right? This is a generic interface, but the generic interface kind of it's not like in the same way that like alloc. When you in Zig, when you call like an allocator, it returns like this concrete type, std mem allocator, and he does like dynamic dispatch with a pointer and a vtable, right? But this buff reader thing, he is not returning this like concrete type. You can make him return a concrete type that does the same thing, but he's actually returning a like another templated type, for lack of a better word. So I think that like we could do the same thing here, where we kind of take in an any type here. So we could say like this is our type, and we return a new type from this. So this is how you do like generic programming in this language. This is like compile time genericism versus like runtime, and then you just return a new structure. So we'll do it that way, and then we'll say a reader is a T, and then like the typical Zig thing people do here is they write another thing, XML lexer, with a lowercase x, and this returns based off of the input reader. They typically do this where it returns an XML lexer of type of reader. This is like the typical approach here, which allows you just call kind of like return this, and it will like auto resolve the rest of it, which is kind of nice. I guess we actually kind of want like reader is a reader. All right, so that means that we can do XML lexer with our reader, and I guess we'll see what happens. I guess let's just make sure that this still compiles and runs. He does not, because this needs to be a variable, because the buffer needs to be modified in order for it to buffer stuff. That makes sense. Okay. I just finished watching your Zig Huffman video. Interesting using an array instead of linked list tree. How can I search further for that approach or read a bit more about it? You said something about Rust brainworm for that approach. Oh, that was probably I was doing something like data had like some U32s or something in it, and then I probably had some sort of like tree structure that pointed into that was like another bunch of U32s. So this would be like a bunch of T's, and then a tree was indexes into the data. I don't really know where you can read more about it, but it's just because in Rust you can't do like self-referential pointers. So if I did like yeah, there's something about this where like if you want to hand out references to this data and it's like a vector, we're mixing like all sorts of languages here. Kind of like when you have like these like growable arrays, these things like move around. The pointer addresses move around, so you hand out indexes instead. I don't know where you can read more about that. It's just kind of like a thing that I do because it works. That's an interesting boilerplate. Why not just call XML lexer? Because this guy returns a type. So if you were like a user to use this, would have to do something that's like lexer is a XML lexer type of reader is how they would have to do this. So you just kind of like wrap that in a function for them so that they don't have to do like the shitty type of magic. Okay, so I guess this guy's gonna have to do something. What's he gonna do? I guess we kind of know a little bit about the XML format. I guess we're probably gonna want to like, you know, look for some sort of token, right? And the token, I guess, can be defined externally here. Doesn't have to be kind of tied to the implementation of XML lexer. And let's think for a second. It would be kind of nice, actually, if we could like store the whole thing there, but I guess it's fine. This is probably going to be actually more like a union with backed by some enum. And let's just like open the XML spec and kind of like just try to find like the first thing we're gonna see. I think it's here. Document is prologue element, etc. So let's just double check first of all. Does our Wayland XML have this? He does. He does have the prologue. So we're looking for XML decal, which is this. So a document must have this prologue, and a prologue has an optional decal, and then a bunch, like one or more, zero or more musics, I think, followed by 0 or 1 doc type decals with music stuff associated with them, I guess. Seems reasonable to me. So really all of this stuff could just not happen, right? This could not happen. But since we do have it happen, then we'll look for it. So we have decal. XML decal. And he is going to contain some sort of data? Maybe? Maybe not, actually. Maybe... I don't really know how this is going to look yet. So let's kind of start with like the simplest thing, which is that we'll kind of say that we have like a token type and a token. Okay. And what we can do is maybe say where that token is. Maybe where it starts and ends. Maybe. That seems reasonable. I don't know. And I guess now what? We basically have to look for this string, right? So we basically want to do like if, I guess we want to read some amount of bytes from this thing. Right? I guess it's going to be like read. How does this thing work in? The Zig standard library. Mlug be like, therefore, you know that you could use the built-in docs and run an HTTP server locally. I'd be like, yeah, Mlug, I know, okay? I'm just not going to do it that way, okay? God. He's not even here, just catching strays. Okay, so what's on this thing? Read all. Read byte, probably. I wonder if we kind of want to do like byte by byte. XML parser limited to 4 GB XML's Monka S. Hell yeah, baby. Hell yeah. Read byte probably makes sense. Like, I'm trying to think like what's gonna happen here. When we like start switching between things, but I guess it's stupid to think ahead. Thinking ahead is for nerds and idiots, and so we're not gonna do that. We are instead just going to... Is there like a way to like peek what comes out of here? In this like buff reader? Because that might be like kind of nicer, to be honest. This guy has like read and reader. Yeah, so nothing crazy here. So I guess... I wonder if we do something like we like kind of like buffer the things that we've read that we haven't quite decided yet what it is, right? That allows us to kind of do something like where we take an allocator here and then we do like in buff is equal to stud array list u8 initialized with an allocator. And then you could do something like in buff resize, I think it is. I don't really know. We'll try it. And then we can do like, I guess we want to add 4 elements to it. If self in buff len is less than 4, something like this. We need to make it at least 4 long. Then read stuff into it. So I guess we need to read however much hasn't been read yet. Hand wavy, right? Like, we're trying to basically get to the point where we have a buffer of these 1, 2, 3, 4, 5 characters so that we can like check if it's the XML decal. I'm sure that there's a stupid, like this is a stupid way to do it, but it's also like the first thing I think of. So, we can always like start there and iterate if we need to. So we can look at self in buff items, and we want to actually do this from self in buff items len onwards. Yeah, and then we probably want read all here. Okay. Now at this point, we're guaranteed that our in buff has enough stuff in it. So we can say like if in buff items, if this is what is it, equal? Yeah. If this is the same as whatever they're asking for, XML, like, right? Then we're fucking cooking. Right? Something like this. Something like this. So then we can say we return. I guess we need to like find the end now. Right? So there's version info, which doesn't look like it has any closing braces. Like none of this stuff looks like closing what is this called? Angle brackets? So I think that it's fine to just hook it and look for this. I think it's fine. So how do we do this? I guess do we want to like return the data instead of like start and end indices? I wonder if that makes more sense. Like, fuck it. We'll do start and end. So I guess we're gonna say like position is going to be U32 as well. Alcohol Q, thanks for the resub. Much appreciated. Much appreciated. I could create my own peekable reader. That's also true. That's another option for sure. Which is probably going to end up being what I would do anyways, but we'll see. We'll see. It'll evolve over time. So if we want to return the start and end, we have like our pause. So here I guess we say, at this point, the buffer position could still be 0, right? This could be kind of like where the start of in buff is in the file. Okay, sure. Then what? I don't know. So basically, like, we have this, like, we need to read from this thing until we find the end thing, right? I guess that makes sense. So we could, like, read in chunks of some amount. We really are just re-implementing a buff reader. So maybe we will take this buff reader away later. But I guess this also lets us read in small chunks. So I guess we could say like, while self in buff items, while this like doesn't end with what we're looking for, this is a stupid thing to do, but you know, we'll iterate. So we can gotta do like, while this thing does not end with the end tag, right? Just keep reading. Right? So we can do like self reader read byte. And what is like the read byte thing? Read byte. He returns a thing. Yeah, so we can do try. And read a byte. Yeah, so we'll just do self in buff dot push this append in this language, I think. Sure. I don't know. We need the allocator type here. So it's stood mem allocator. Do you have an interest in cybersecurity too, or mostly just software? I haven't really done any cybersecurity, but I was thinking like literally 2 hours ago that it would be fun to do some of those like capture the flag things, because I do want to get into it. Specifically, I want to be able to do things like, I bought this GameSir T4 Khalid controller, which is pretty cool. Except like it has like paddles on the back that are not remappable. They're not in the Linux driver as like individual buttons. The firmware kind of just like hard codes them to other buttons on the controller. And I was like, it would be nice to be able to kind of like hack the firmware on that thing and like fix it so that I have just like 2 extra buttons. That would just be kind of like nice. But then I like, I open up their like firmware and I'm like, oh, this is like too hard. This is too hard for me with my current level of knowledge. Like I couldn't even figure out like what was in their firmware package, And I'm like, it would just be nice to be able to like kind of have the tools to poke a little more around in that thing. So it would be cool to get into like reverse engineering and stuff at some point. So it's definitely on the list of things that I want to try at some point, but I don't know if it's going to be like the immediate future. Okay, so then at this point, we should be able to. At this point, we should have the end of the buffer, right? So we can do like the start is going to be self pause, right? This is the start. The end is self pause plus the size of inbuff, right? And the type is just XML decal, which seems kind of reasonable. I'm sure that we will iterate on this at some point, but this feels okay for now. I guess maybe eventually this is going to turn into like we might have several like accessors or something. Like we might have like read byte by byte until you figure out which thing you are, then rip through or something. I don't know. We'll see. I'm kind of talking out my ass. But we should be able to call like Lexer next here. We can say like const token is equal to this, and we should be able to get a token out of this thing. Should be. I mean, we probably did it wrong, but we can always dream. This XML Lexer does need an allocator now, which kind of indicates that we need like a Lexer D in it. Kind of indicates that, doesn't it? So we need like a pub function D in it of self XML Lexer. And it looks like it's just going to call self in buff D in it like this. Okay. Next, expected type found. Oh, right. Because XML Lexer is now not allowed to be used. That's a function. So we need a type. So we're going to say const self is equal to this, I think is what they do. And then here we just replace all these guys with self. Boom. Okay. And expected array of U8 found this thing. Whoa, hold on. Oh. Because it's already a slice? No. Yeah. And then we need to do something with number of bytes read. But for now, we will do nothing. Incompatible types, he expected, yeah, this is inbuff.len. I'm an idiot. And I guess we incast this because it's a usize. Items.len, and I think the incast actually goes here. And we also forgot to set pause. So after we return this thing, we should clear our inbuff. And update the position. So it's kind of like we want to do this kind of like after the thing we return. So it's kind of like clear retaining capacity, which can't fail, and then self pause plus equals self in buff items len. All right, let's see what happens there. We're still in compile. Right, because this needs an incast, of course. Of course, and what's he mad about? Function with non-void return type. Oh. I guess we'll return an error or something. Or null. If it's not this, return error unknown symbol. I think that's fine. Missing field pause. Right, so when you initialize this thing, pause has to be 0. D init, did I spell D init wrong? D init. There we go. Much better. Okay, so we get unknown symbol off rip, which is kind of surprising. So can we print out what this thing is? Nothing. Nothing. That's kind of surprising. That's actually quite surprising. Can we look at like the len? So it is 5. Can we print out as like hex? It's all A. Oh, I'm a dumbass? I'm a dumbass? I read past the end of the buffer? Won't that while ends with never stop looping if you don't have the end token? Yep. It sure will. It sure will. But it will actually probably crash out here, because this read byte will fail with end of file, which is maybe a problem, right? Well, like if we're trying to don't keep all history, right? We probably don't want that. But it's okay. We'll figure that out as we go. Could heap allocate way too much. All right. So this needs to go from actually the old len. So we need like old len is this. Oops. Kind of this, and then we read from old len onwards. There we go. Old len. That's what I just typed there. Okay. So there we go. So now we have a token that we got from 0 to 38. Let's fucking go. 30 minutes in, and we've parsed 1 token. Sick. Sick. All right. So what happens next? I guess we just do this in a loop, right? We try to get a token. Print the token. So immediately we get an unknown symbol, which makes a lot of sense, right? And so now the question is, how do we handle this? So what is the next thing we get? What is the next thing we get? Can we print it as a string instead of as hex? Let's go back to string printing. Okay, so we see some like white space followed by pro, which makes sense, right? That is what is right here. So we see like a new line and then protocol. So I guess we kind of want to consume white space as we go. Okay, how do we do this? My first thought is to replace this part where we kind of like read in a bunch of stuff at once. I kind of want to do like while true, do a stupid thing here, inefficient stupid thing, but something that will work, where we kind of read 1 byte at a time. Okay. And we append this to our input buffer, right? Kind of just like we were doing here. And then we can kind of like every iteration, we can check if this matches any of our like known token starts. So we can have like const token prefix as like this thing. Right, we can do this. And presumably this is not a valid Zig thing, so we put an @ in front of it so we can use it as an identifier. And then we can have another one here that is just, ooh, this is tricky. So we can't just match any open tag here, right? If we do this and we try to kind of say like, do we get this or this? this is kind of like a more specific case of this, right? So we don't actually know that it's not this tag until we've parsed more than the beginning of the thing, right? So if we were to kind of just say parse characters until I can like see something, then we would never see this, right? So there's like, I guess, a couple options here. You could kind of start with this turns into either this or anything else, right? That's one option. Another option is that we have like priority, right? So we kind of say check this thing first, like start walking from top to bottom as like the thing that's the most important to match, then work your way down until you get something else. That's like another option. And another option is like state, right? So this like question mark XML thing is only valid at the beginning of the file, I would assume. I don't actually know, but it's a guess. So that's like another option. I kind of feel like state makes sense. It kind of feels like state machine makes sense, especially as we advance into parsing like XML attributes. Like when you have like you have like name key equals value, right? Like something like this, we're surely going to have to be like in like some sort of inner state in here, right? Parsing attributes, right? So it makes sense to introduce the concept of state. And I guess even then though, we're going to have to go through this like fallback, right? Where if we don't see this XML header, we still can just fall through to the next thing. So we don't actually know that we've left the searching for XML state until we've already found another thing, right? Because as far as I can tell from the grammar, this prologue is like pretty much completely optional. So I think that we save the state machine for later and figure out how to disambiguate between these two things first. And my gut kind of says here, I kind of like the idea of like feeding multiple things that are like telling us, hey, do I think that this is going to be, how to say this? Do I think that I am a potential match for this, right? So when we find like the first angle bracket, we might be able to say like, oh yeah, both of these guys return like, yes, I'm a potential thing. And then we see the question mark, this guy goes like, whoa, that's not me, bitch. Whoa, sup guys? Bash Bunny, thanks for the raid. What is up? Hey guys, we are working on an XML parser for shits and giggles. We have this Wayland specification that we were trying to parse. We have previously parsed this with libxpat, but we kind of want to roll our own XML parser because it's fun. Now we also need a couple days or a day or two of break from this like long-term project we've been working on of making a virtual GPU. So we've been working on this thing for a little bit, where we've been working towards writing like a virtual GPU in QEMU and a kernel driver to go with it, and eventually a user space OpenGL implementation to go with it. But we were banging our heads against the wall a little too much yesterday, so we needed a break. Yeah, after yesterday, a break is needed for sure. So hopefully a couple days on this. I'm hoping if we go over 3 days, then that's too much. But that's where we're at right now. How do you say your name? Spherophore is how I say it, but I don't really know. It's just a word that I like found on the internet one time. I was like, oh, I like that word, man. But I never looked up how to say it, so you know. Okay, so I like this idea of being able to feed our XML parser to say like, yeah, which states are possible right now? So maybe we have some sort of like mapping. Some sort of mapping of like thing to token prefix. So you have like, let me think about this. So I guess for each one of these, you're going to have like, how many characters into this have I processed? And is the next character good? So what? You have like prefix validator. I don't like this name, but it's the best one I've got right now. So I'll say, fix me. I don't like the name. And so I guess like the obvious thing to do here is to write like XML decal. We have like some sort of like concrete implementation of this thing, probably. I don't know. And we're gonna be like, is valid, or like push a byte. Yeah. Right? We push 1 byte to this thing, and he'll return us true or false. Right? So true means keep using me, and false means no, I don't want to be used anymore. Right? So we'll also keep track of like how far into this thing we are. That seems reasonable to me. This can probably be like a U like 8 or something, right? Because we will never go farther than like this many bytes in. And then we can say like at the string that we're validating against is this, right? This is what we're looking for. So we can just say if s at self pause XML decal prefix validator. If this is equal to B, we are chilling. So I guess we just return this, right? That's kind of like what we're discovering here. And we defer self pause plus equals 1. I feel like this would be a cool grammar tree problem. You're assuming that I know what a grammar tree is. But I'm sure eventually we'll discover some interesting thing out of this, but I don't really know how. Okay. So I guess this looks a lot like a generic thing, right? We're going to be doing this exact same thing for other things. And I guess the other problem here is we have to check if self pause is less than slen and this. This is how we determine. And so this is certainly just going to be true for all of these types. It's just the string that we're comparing against is going to be different. You could do this, I guess, fully runtime, but I don't know if that's what we want. Not sure. I kind of think that also this guy should have like a type associated with him so that we can extract that this means like that he is a XML decal, you know? That's kind of like, it just kind of feels like that's going to work that way. So we're going to want like token type. It just kind of feels like this is going to make sense. And then that way you can kind of just say like, which one of these things worked? Okay, that one's like, we only have one left. We only have one of these things left. What is its token type? In which case it kind of feels like we're going to have like an array of these things, right? We're going to have like an array of validators, and we are going to run them all, removing the ones that don't work until it's fine. So I kind of like the idea of this being like, this is going to be we're going to have like some sort of like generic interface here. Is kind of how this is starting to play out. Oh, sorry. I'm like missing a lot of stuff. How's your day? Good. How are you? Oh, boys isn't Zig. Yes, I guess the grammar would represent the XML as a language. Yeah, I think that like there's like typical I've seen like these like grammars that you can write that are like kind of compact ways of doing this. Like these things are like very grammar languagey. And I'm sure you could like somehow intentionally write like a parser that does these things like generically, but I don't really know how to do that, and I don't want to. I'm just gonna write whatever code makes sense. So this is gonna have a vtable, which is gonna have some functions in it, right? He's gonna have push, which is going to be like some function pointer. I don't remember how function pointers work in this language, but it'll become clear soon. And this is going to take in instead a context of any opaque. And I think that you have to put a star here for the any opaque to work correctly, I think. We can look at the allocator implementation, and that will give us some clues. So they write pointer with pointer. Okay, so they write const function here. Right, that makes more sense. Function pointer. I think this is how we do it. So we have push, and then we have a token. And this is going to take in the maybe nothing, maybe the context, maybe nothing, and return a token type. I guess there's no reason not to take in the context. We'll see. Maybe every single implementation won't use this. Yeah, I feel like they won't, so we'll do it this way. We'll do it this way. I guess this could just straight up be like this. So it's not even part of the vtable. In which case, having a vtable is kind of silly. So we can just do it this way. We can just do it this way for now. Okay. It's how JavaScript's eval function works. Yeah, that makes sense. Makes sense. It's just we tackle things as we need them around here. Tree Sitter is one of those. Yeah, Tree Sitter is pretty cool. I should check out Tree Sitter sometime. I've been kind of meaning to do some sort of like play around with that. I at one point wanted to write like a diff tool that uses Tree Sitter under the hood. Somebody else has already done it, but I want to do it as well. Okay, so I guess the reason to hide this behind a vtable thing though, that's actually still valid. Because if we have this member here, we can't write a function called push on this thing, which is kind of annoying. So I'm going to go back to putting it in the vtable, even though the vtable has nothing really in it. Nothing really in it. Okay, so then we can write a function here, push, who takes in a prefix validator and a byte, right? And all he does is he just calls self vtable push. He also needs a context here. So he's going to push with the context and b. Okay. Okay, so now we're going to have like this XML decal prefix validator thing. And he's going to instead take this thing as any opaque. So the types match. And he's going to say self is a XML prefix validator, which is a pointer cast of opaque. Is opaque a reserved keyword? It might be. It might be. Context, we call it. There we go. He likes that a lot better. He likes that a lot better. And this is still fine. I guess you could also argue that if all of these guys are going to be like string comparers, then we can actually just kind of say we don't even need this push function. We can just kind of put the string here. Yeah, that makes way more sense. Yeah. That makes way more sense. Yeah, that feels pretty good. And then the implementation of this push function is just this. Which means that he needs this pause thing as well. There we go. We got there. We got there. It took a minute, but I guess I want to keep this fixed here. I'm still not really too keen on the name. And he's mad at S here. So this S turns into a self string. And okay, unreachable code because this goes away. All right. Wow, it took us a lot of typing to get here, but we got to like a 5-line thing. Hell yeah, dude. Okay, so I kind of think that we're gonna have kind of like prefixes or something. I don't know. And I think this is gonna be like an array of these things. Is kind of what I'm thinking. Maybe an array list. And if we have 2 array lists, then that means we kind of keep our allocator out of band so that we don't waste space here. So this becomes like this now, like this, and this is unmanaged here. Okay. So my idea here is that we kind of push these things byte by byte and swap any ones that pop any ones that return false. So we're gonna need some sort of like reset prefixes. Maybe we'll take in a std array list unmanaged of prefix validators. which means that I kind of want like a name for this thing. So I want like a prefix list is this. Prefix list. Okay. And then this can take in a list of prefix list. Maybe we'll call this prefixes. And here we're going to like basically push a prefix validator for each type. Why Zig and not Rust? As I'm a Rust dev, I'm trying to find an excuse to learn Zig. The biggest thing is it allows you more freedom, is what I will say. There's, Rust patterns that will not work in Zig, right? Because the type system is kind of less geared towards like type neuroticism, as we could call it, right? If you want this world where every single thing that you could implement can be perfectly expressed by the type system, Zig isn't really that. But it also is a lot more freeing. You can like sometimes the thing that like really kicked it for me was that sometimes you just want to do something that you know is wrong just to see what will happen before you go through all the work of implementing for real. And Rust really often prevents you from doing that, which is great in a lot of contexts, but frustrating when you're just trying to like rapidly prototype something. And so Zig lets you do that while keeping a lot of the like learnings of like what have we learned about what makes a good programming language in the past like 15 years, right? Zig kind of keeps a lot of the stuff that makes Rust cool in that like it's got like pretty good, like its memory safety is like a lot better than C. It's like there's still things that you can do. You can still kind of like give a stack pointer, accidentally leak a stack pointer to somewhere that you shouldn't have, but generally it's like pretty good. I kind of think of it as like Rust is to C++ as Zig is to C. Would be probably the best sell I could give you. And if you're like, I like C++ over C, then you probably wouldn't like Zig over Rust, would be my guess. But you never know. Okay. So what are we going to do here? Perfect explanation, thank you. No problem. Okay. So I guess we're going to push this thing. So first we're going to say, I guess we need an allocator here as well, because this is an unmanaged array now. And we're going to be like prefixes clear retaining capacity. And we're going to then push all of our things. So we're going to be like, I have one for each type, essentially, right? So it's going to be like prefix validator token is XML decal. And if we're trying to do an XML decal, then we need a string is this. And then here, what's our other thing in here? Pause. Pause is always going to be 0, so we can just kind of on initialization, so we can just kind of leave that out here. Okay, so now we have this. We can just say that we have another thing that's like a, I don't know what the name of this other thing is, like a normal fucking block. Can we look for like a document? Document. Where was it? It was like here somewhere. Document is equal to this element. So we'll call this element. An element starts with this. All right, so we need an element here. And then all we have to do is as we walk our thing, we're going to basically go for all our prefixes. I think it's items here. We'll be like, if prefix push the byte we just got. If this is false, then we remove the thing. So we're going to have like a list of items to remove. So we're going to say this is going to be like indexes with initialized with our allocator. I guess we could do this as like with a known capacity on the stack. Fix me, maybe stack array. It's fine. But for now, we'll do it this way. Var to remove is equal to this. Okay. And so if this is true, we add this to the to remove list, which is going to be the index here. So that means we need to keep track of the index like this, and we append the index, and then at the end, we just go while to, I guess we need to defer to remove deinit, boom. And we'll say while to remove items len is greater than 0, to remove pop. And does this give us the item? Oh, we can actually do while to remove pop or null. We get the index, and then we just do a little swap and pop. So we go self prefixes swap remove index. Boom. Bing bang boom. Haha, little tweet from Andrew. The worst zig. Uh-oh. The worst tech ever. The zig is the C player placement while XYZ is the C++ placement. I see this so much it makes my brain numb. Uh-oh. He's saying fuck C++. I mean, that's true. C++ is also really bad. But I mean, like, I don't know if that's like, I mean, he's saying it makes his brain numb. But like, also, I mean, you don't have RAI, which I think is a real core of C++. Like, I think it really does land closer on the scale of, like, if you were to say like simplicity versus like type neuroticism, like it's really closer to simple to me. So, you know, he can say what he wants and I can say what I want. I like the language and it feels more C-like to me, so I'm gonna keep saying that, even though he doesn't want me to. Can I do oop in Zig? I don't really know. I've been programming for a long time. Sorry, Izarin. Thanks for the sub. I've been programming for a long time. A lot of it doing object-oriented programming, but I'm not gonna fucking lie. I don't know what object-oriented programming means. Like, we'll just be honest, right? So, like, you can do object-oriented programming in like C, right? You can have interfaces. Interfaces can inherit. You can roll some form of inheritance. The inheritance model in Zig is much closer to what you would see in like a C language versus like a C++ or Rust language, right? Where you have like context pointers or field parent pointer offset type things, where you have like you embed the base class in your child class and stuff. But like, you could do it, I guess. I think yes. The answer is probably yes. It really depends on what you mean. Yeah. Okay, so this goes away. And I guess eventually we're going to have one element that's left, right? That's kind of what's going to end up happening here. So, hold on. I guess we start here, and then we do we even need to keep the in buffer? We might not have to. We might not have to. We'll kind of see where we end up. I guess we will keep stuff in the in buffer now though, because it's easier to kind of integrate with the rest of the code that we've written already. So we will just do this for now. And I guess we'll say here, if while self prefixes items len is greater than 0, greater than 1. Once we've got to 1, then we're done. So here, we'll say, okay, we have one prefix left. So we can say if we have 0 left, i.e. we didn't get a angle bracket at the start, then return error not in unknown token, right? But otherwise, then we have one thing. Debug assert self prefixes items len is 1, right? This should be guaranteed true here. And now we can say, what is our token type? So self prefixes items 0 token. There we go. I think this gets us here. So now in this stuff, we can kind of like switch on the token type. Oopsies. And this is what we do for XML decal. Right? And we're going to do something very similar for element. Except we're just going to look for this. Fix me handle escaping, etc. We should kind of do that here as well. But for now, we do it this way. Okay. I guess even this looks a lot like we could actually kind of factor this out as like end sequence. Okay, which means that this just returns this, and this just returns this. And then this ends up down here, looking for end sequence. Yep, that sounds right. That sounds right. Cool. Then we're kind of donezo, and we can say, here's our thing. Maybe. Maybe. Then we have some things here where this guy needs an allocator passed in now. Probably other usages of inbuff are going to have the same problem. Okay. And then I think that we actually fucked up here where we have to call reset prefixes sometimes. So we also need to call self reset prefixes. And then probably off rip, we need to call reset prefixes as well. So we'll kind of say here that we have like alloc, just go alloc. This is no longer, since these are unmanaged buffers now, we don't have to initialize them in init. We can kind of say with this. And then I guess what we'll do is we'll say like var ret is equal to this. Which means that we kind of have to resolve the type here again, which is a little annoying, but it's fine. And then we'll say XML lexer. I guess we'll say like ret type here, so that we can use it twice. And we'll have like ret reset prefixes, alloc, and ret dot prefixes like this. Boom. Boom, boom, boom. Maybe that works. He doesn't build, of course. So 75. I think that needs to be passed come by pointer because it's non-constant. 81, when we swap remove, we do have to do something, but we will just do this. Ignore. Reset prefixes does not exist. Really? Why not? Oh, because... No, I'm a little confused. Hold on. Struct declared here. Member function expected 0 arguments found 1. 53. Yeah, that's true. I don't know why I passed something there. And then error union is ignored at 55. Right, these do have to be tried. All right. Jesus. I think that I'm kind of surprised. Oh, reset prefix is not a member function. But this is a type. Right? Yeah, so I'm kind of surprised this isn't allowed. But I guess we can kind of pull this out and then it kind of fixes itself. I think that that will do it. Which means that the prefix list needs to kind of come out here as well. Does that fix it? Oh! I'm just an idiot. It was the wrong spot. All right. So this actually can't be done here. So we can't do this in a defer block anymore. We kind of do like this instead, where we have like a ret up here, token like this, boom, boom, boom. Then we do all this stuff after, and then we return ret, and then this is tried. Okay, and then another what error unit ignored down here. And what's it mad about now? Expected type that found that. Oh, because here we're not returning an error probably. Lexer next, nice. No field or member function named next. Oh, because the XML lexer now needs to return an error. Nice, okay. Member function argument expected, right? Because in our dinit function now we need to dinit with self alloc and also dinit our prefixes. All right. So he's mad here probably because the unknown token is white space. We need to skip white space. So let's think about this for a second. We're going to assume that no prefixes have white space. So we can do like if stood ASCII is white space of B. We can just kind of like continue here. We still push it to the in buffer, I think. No, we don't. No, we don't. Let's try that. Okay, so he still finds an unknown token. We should probably say what the unknown token is. So can we say like stood log error unknown token, and can we log maybe the like self in buff items, right? What do we get that we don't know how to parse? Unknown token thing P. Oh, because our prefix parser here, he should stop incrementing pause if we've already hit the length. Right? It's always an option to do this, even if we keep going. This one will stay an option, right? Because what happened here is that it thought it was looking for like with a P at the end. And he goes like, "Whoa, this doesn't match our thing," but it's because we weren't supposed to keep going. Yeah. Yeah. That feels right. Okay, so now we got an end of stream, which is maybe good. That means that we have successfully identified that we have an element type, but we have not successfully. So this is at 73. Poll parser or eager one? I don't know. I don't know what I'm talking about or what I'm doing. Okay. So what's going on here? He hits end of stream before even hitting the first token? Am I stupid? Am I stupid? Land a PBS, thanks for the prime, much appreciated. Yeah, here we don't get a single token, right? We don't anymore. So we've done something stupid here. So I guess we should crack open the debugger. It's the only thing that makes sense here. Do we have GDB? We do. So this is custom XML partner parser with res wayland.xml. And we're going to do with args, rerun it. I guess we don't want to break at 73. Oopsies. Break at custom XML parser 73. There we go. .sig, my bad. Okay, can we run this bad boy? And can we just kind of see what happens here? Maybe we want to do like dprintf on line 74. So can we do this 74 print the character, I guess? Okay, so he is just ripping shit, right? That kind of makes sense. He is just ripping shit. And I guess why? What did I miss here? What did I miss? So I guess that kind of means that self prefixes len must stay greater than 1. Oh, because Right, what ends up happening is both of these guys get matched now, right? But they both keep matching forever. So we also want like a finished or something. Yeah. So how do we do this? I guess we return this, right? And then I guess what we do is we take the longest thing that matches, right? That kind of makes the most sense. So basically, if something is finished, we consider that the thing that we want to use. And if we get a new thing that's finished, we consider that the new thing we want to use. And as we keep replacing, we'll keep getting a longer and longer and longer thing that matches. And we might need to tie break later in some way if they're like the same length, but we can kind of handle that as it comes. Sure. So now the question is, can we like remove some stuff here? I guess we will only ever return true in the case where self pause is exactly equal to string length. No, we kind of need kind of like tri-state, right? We kind of want to say that we're like either feeding, right? Feed me more. I am matched or not matched, right? So kind of like by default, we're gonna say like if self pause is equal to self string len, we return matched. Okay. But this is kind of after we push. Right? So we kind of want to do like car matches is equal to this, right? If the latest byte matches, call byte because we're using the word b here, letter b. If the latest byte matches, we will return different behavior here. So if byte matches and this, we return matched. Else if byte matches, I guess we return, yeah, else if byte matches, return feeding. Else return not matched. I guess not matched is a bad name here. Not a match, I think is more clear. Okay. So then when we push these things now, we say switch on this thing. So I guess we kind of like yoink this, put it here. And if it is matched, we are going to say that the potential which is going to be a prefix validator, or I guess a token type, I guess. Yeah. Okay. Maybe this even comes up here. Then here we say like potential match is equal to prefix dot token. Okay. If it's unmatched or not a match, we kind of do what we were doing before, where we kind of like remove that thing. We're like, okay, this is no longer in our list of things we care about. And if we are feeding, we do nothing. Seems reasonable. Then at the bottom, we don't look at self prefixes anymore. Oh, I guess even if it is a potential match, we still need to remove it from the list of things we're checking. Right? We no longer care about this one. We know it's a potential match. We move on with our lives. That seems reasonable. So now, instead of doing this, we say, we'll call this token type is equal to potential match, or else return error unknown token. And I guess it does make sense to still log here. So we'll just say if potential match is equal to null, we'll do this. Then we'll say const token type is equal to potential match, like this. Boom. I guess we could have done it a little more concise. We could say token type is equal to potential match or else, and then do this. Yeah. All right, let's see what happens. All right. Wait, this looks good. This looks good. So we got XML version, protocol type, copyright, and now we're in like data. Now we're in data. Sick. Sick. Guys, we did it. Look at that. Look at that. We have a we've parsed 3 tags. 3 tags. Look at us go. I guess we should kind of say that we've kind of like at some point we did parse first line, and now we're gonna say parse second line. And now we are at trying to parse descriptions. So it is 01:16:15, and let's say parse description. Okay. All right. So what happens here? I actually don't know. I assume that this stuff gets the leading white space removed. I assume. Can we look at like where in the language is this thing? Oh, white space handling. Okay, it is often inconvenient to use white space to set apart markup and readability. Such white space is typically not intended for inclusion into the version of the document. On the other hand, significant white space should be preserved and delivered. An XML processor must always pass all characters in a document that are not markup through to an application. Okay. A validating XML parser must also inform the application which of these characters constitute white space appearing in element content. So it looks like he's kind of saying that we should be passing the indentation in the copyright onwards, but the consumer can choose to remove it. Is kind of like what that sounds like. Rye poopy. Great. Thanks for the prime, much appreciated. And I think the other guy. What Linux distribution is this? This is Nix OS, but I don't really think it's that relevant, to be honest. I think use whatever you're comfortable with. It's one of those things where it's like, in the same way that I wouldn't tell people they should use Vim, I don't think I would tell people to use Nix OS. However, if you're looking for what Nix OS provides, then, I think it's a good fit. Been following the Homebrew GPU series. Did XSpec get boring or something? I just need a couple days of a break from that one. We had kind of like a couple rough days of just like not very much progress, and so sometimes a context switch going back and forth will help. I am very confident, very confident that this is not the end of the GPU project. I'm planning on spending like 3 days on this or something, tops, and then we'll be back on it. I just need a break. Sometimes that happens. Kind of benefit of doing what I feel like is that at work, sometimes you just have to like put in the grind on that stuff, and it sucks, man. It's so frustrating when you're on like day 8 of just like, oh my god, this sucks. I'm not getting what I want to get done. So it's kind of nice to be able to just like take a break because I feel like it. Okay, so what now? I guess we're kind of like the default state here. The default state is kind of that we are in a like data segment, right? What is it called? Like the stuff in the between the brackets. Element, empty element tag, s tag, content, e tag. So it's called content. I guess you can't have content unless you have just finished an open tag. So this is where state in our parser becomes important, I think. So we'll kind of say that we have like some sort of like Lexer state. I guess calling it a Lexer now is kind of disingenuous if it's not. I don't really know like the difference between a Lexer and a parser is. Yeah, this feels more Lexy still, so we'll just say Lexer state, and we'll call this a Lexer state, and we will eat the pain of people online telling us that we're idiots for calling it that. But we just have like two states right now. We have like content or prefix or like none or something, right? So none is like looking for a this thing, and content is between these things. Now, I guess that's also not really true. I guess, yeah, I kind of take this back. I kind of feel like you should always be willing to take some content. Maybe not at the top level, but fuck it. Okay. So I guess what this means is we just kind of like eat stuff until we find the next leading thing, and we emit that as content. That seems reasonable. So we're basically just going to look for what I assume we just look for an open like open tag. I'm assuming that I haven't read that in the spec. But we'll see. Lexer makes tokens, parser makes AST. Yeah, I kind of feel like I'm not finding a like I'm not making like a tree, which makes me think that this whole thing fits more Lexery. But I am also giving it meaning. So it's like I feel like the definition that I have in my head is like just not really solid enough for me to be able to disambiguate between the two. Right? Because like the thing that I'm planning on producing here is like a stream of tokens, kind of, which seems Lexy, even though it depends on the state. Okay. So I guess we want to say like we want to like find the next I don't know what to call these things. Element, tag. I guess we'll call it tag. We will find tag. Simple. Find tag. So find tag. And I guess this will just kind of shove stuff into the in buffer until it finds a open thing. Yeah, open angle bracket. So it's kind of just this. Yeah, so we say this is going to return a like token, I guess. And I kind of want to eventually ditch the concept of inbuff altogether, but for now we'll just kind of keep doing it this way. So we'll say if b is equal to this, then all of a sudden we're going to switch behavior. So we're going to say self inbuff clear, but maybe we'll print what we got first. So we'll say got some text, some content, like this. Okay. And I guess we'll say that we have content token as well. And then this will return the start and end. So we kind of have to do this as well, where we kind of increment the pause, which means like fix me, deduplicate, advance. I guess we can just do that now. So this is gonna like basically do this stuff. Seems reasonable. And then we can call advance here. After preparing. So I think that we kind of want our advance to return our output. That will make this kind of easier to use. So we'll kind of pass in like a token type here, like this. And then this will do kind of this. Boom. Boom. And then you can call return self-advance with XML decal, which in hindsight actually seems kind of wrong, right? This should be returned with the token type. And then here in our find tag, we will say ret is advance with content, and then we push the latest thing. So we kind of need to do it after the advance so that the new angle bracket gets kind of buffered for later. No. We actually need to do our first prefix push. We actually have to do all of this kind of right now because we have a new token to start parsing. So here we'll say like push push token push prefixes. Sure. Sure, why not? Yep. And then this guy needs to probably append some sort of like self potential match now. It honestly looks like we have to store that across runs. I guess kind of hand wavy, you could make a guess here. You actually probably don't need to do this. You could just not do our prefix parsing with the starting tag. And that kind of solves this problem, I think. Right, so here we just kind of remove this leading thing. We kind of assume all of these start with that. And then in reality, then in that world, you don't even have to check the element type. You can kind of assume that we start with a element token type, right? And then any other time, anything else kind of takes it over. Cool. Which I think makes this make sense. It kind of means that this prefixes thing is now kind of overkill because there's only one prefix that we're ever parsing, but you know, you get there how you get there. So I guess this becomes token type up here. And this becomes token type here. And then we're missing a spot here where you need to say if self find tag return ret. Because this will return us like, I guess just be like advance a tag, and then this will kind of like consume some stuff inside and return that. I think that seems reasonable. This shouldn't happen. We should never see content in that part. Should not. Oh, we need to return here, I guess. I guess we just return an error here. Error, unexpected content. Fine. 120, he's mad because this needs to return, which means that these guys need to write try. I guess. 124, he's mad because we called it twice, like a dumbasses. And then here, if B is an open brace. I guess the other option is to return null. I think. Then at the end here, we can print out that we got content here. So we're like content this. We'll just kind of see what happens here. Does that make sense? This needs to be like wow. That makes us more sense. If we're trying to advance to the tag, we need to keep going until we find one. So that means that this will always succeed. That seems right. I guess also this advance will clear it out. So the log of this thing actually needs to go here. And then what? This no longer is like a optional type. But it needs to be. It needs to be. So I guess we're back to needing a state, right? Seems like we're kind of back to needing a state. So we'll kind of hear like parsing tag. And here we'll say if not self-parsing tag, we call advance to tag. Otherwise, we say here self-parsing tag is false. And then after we parse the tag, I guess we kind of can do it in the advance. Kind of feels like where it belongs. Right, we can kind of like switch on token type. And if it's content, we say self-parsing tag equal to true, else self-parsing tag is equal to false. That seems right to me. That seems right to me. So that means that like that we will end up calling this like find the next tag start every time we get anything but content. Feels right to me. Might be stupid, but you know, you never know. Advance needs to error out, which means that everyone who calls advance needs to write try. Okay. So that actually looks pretty good. Maybe. Fuck you. Fuck you. I'm missing my keyboard a lot. Okay. Right, so we get content nothing, then we get a token. Then we get this thing. Zero to 37. Is this right? So we get content 0 to 0, then we get this 0 to 37. We get some content, which is just a new line. Then we get the protocol name Wayland here. We get some content followed by copyright. Then the copyright content. Nice, nice. That actually is starting to feel kind of correct. Kind of correct. I would like to have the end tag a little bit more clear here. But otherwise, do we make it to the end of the thing? We get to close protocol. Which is the last thing. So we have successfully walked the whole file now, which is good. Which is good. We are not doing a lot of like useful things with this, but we have made it to the end of the file. So I think that's pretty good. I think that now the next thing to do is to disambiguate end and start tags. Disambiguate start end. Okay, so let's kind of try to do that next. Let's add source custom XML parser and build.zig and just say like whip Also, why am I not... Oh, I see. Am I in the middle of a rebase? It doesn't look like it. It just looked like I checked out origin wib. I hope so. Yeah, okay. All right. The baby's first walk. Hell yeah, dude. Okay. So I guess we will add a new one, which is just like a slash. Right? And this is not a decal, this is an end tag. And I guess we'll call it end element. Element end. Element end. Seems reasonable. So this should actually just work with what we have now. Detached from head on origin master doesn't look too great. Yeah, I don't know. Don't worry about it. Don't worry about it. I do this all the time. We can do git checkout dash b whip 2. It's fine. It's fine. I don't know. I'm detached all the fucking time and I really just don't mind it. So element as well as element end are going to look for the same closing tag. Is it comma in this language? I think it is. There we go. So now when we see our protocol end, this should say element end, which is very good. Very good. Okay. All right. So now I think it probably makes sense for us to try to like, wow, that was very fast. It probably makes sense for us to try to keep the name. Don't lose name. My head is always attached as well. Hell yeah, dude. Right, what probably makes sense here is that the we can go back to a union here on the token type. And maybe these guys have like names, right? Is that how I want to do it? Maybe each one of these has like a list of fields. Maybe. So like as you parse the name, you have like a name field followed by a bunch of other stuff. Maybe we can also kind of assume that everything has a name. Is that true? No, because like a comment, this does not have a name. But like this kind of does, right? So maybe we can we could say that like the name is pretty much guaranteed and this will be flagged with like empty if there's not one, but we can kind of like optimize for the happy path or like the common path where there will usually be a name. I think that's fine. So our parser might have like a name. Where we must, like when we parse, we basically are looking for like white space, right? That's how this works. Element. S tag, name. S is S white space? Yeah, S is white space. So we have the name followed by white space or the end tag. Yeah. Makes sense. So in that case, we kind of have like special handlers for each thing. Is that true? Let's think about this. So here, this thing has no name. But if he consumes the XML, then he immediately sees the white space. So we can kind of do the same thing here, where no matter what, we try to look for white space and call that a thing. Yeah. Now, there's a problem there where I guess technically this XML searcher thing, XML decal, should contain this space after, to be honest. Because I doubt this is valid if it doesn't have a space after. So I think we should do it like that. And then yeah, I guess just when we start one of these things, we'll just populate the name. Right? So we basically say that like while something stood self reader read byte. We're gonna say like if B is white space, not like this, stood ASCII is white space of B, or B is equal to this, we have a problem. Which kind of means that we're kind of like, we have to handle the element case different than the XML decal case. Let me think about this. So we want to walk forward. So what I'm worried about here is you could just keep reading until you see this guy and then backtrack to print out like everything you saw so that you can kind of do this search later to find the end tag. But I don't really want to do that. I guess we could. I guess you like if like because I was worried about like over allocating, right? But in reality, like if it is valid for you to insert an arbitrarily long name, then somebody could just make an we could parse an XML document that just looks like this and goes for like gigs and gigs and gigs and gigs and gigs, in which case like it's fine. So I guess we kind of go here and we say self in buff append B and self name append B as well. And this inbuff is strictly for debugging. So this should be fine. I think inbuff is not really... Oh, it is kind of used here. That's a little annoying, but it's fine. It's fine. I think this uses some regex. Maybe. I think regex just turns into code though, so we can just write some code. You know, not the end of the world. Okay. Sure. Then we have to return in here. We return the name. And what's kind of annoying here is I kind of want to keep the name valid. So we can't like reset it right now if the caller is going to look at this thing. So if the caller is going to look at this thing, then what? We can't. So when can we clear it? I guess we can kind of clear the name immediately on next, because we're done with it here. And here we'll say note. We'll just write like name was leased to the caller or something. Sure. I don't know. Seems reasonable to me. So he's mad because error union is ignored at 124. We do need to write try when we use grow some memory. And now he's probably mad that we need to free the name on dinit. Okay. And then we get end of stream kind of immediately. It looks like we fucked something up with this. Because we do just continue forever. So I guess we do that. Okay. So now the question is do the names look right? So can we do like token name here? I could write like a custom formatter for it, but I don't want to. So it looks like none of these names are what I would expect, right? There's also something wrong here where we're missing characters now here as well. Protocol. Yeah, we're missing the R. Copyright, missing the O. So how the fuck did we fuck that up? Oh, I guess the name has to start as inbuff. I guess, right? Because we kind of buffered some input already. Yeah, I think that makes sense. No, he's still missing some stuff, huh? Hum. Wait, what the fuck? Where's my... Oh, we put it pipe into less, that's why. So he does make it to the end, it's just that the names are fucked. Also, the name only is one long ever? Probably because inbuff is keeping everything here. Okay, so on each read byte, if it's white space, we continue. That's fine. Although I guess that shouldn't happen anymore. But we should leave it in here. Fix me probably can remove. Then here we have append byte. So everywhere we read byte, we should append to inbuff. Other than here, which is reasonable. So inbuff should have everything. It should have everything. So if we copy from inbuff into name at this point, then I don't really understand how we're missing anything. I guess inbuff is also missing stuff. Where is reader use? He appends here. He appends here. Probably this. We are missing one there, but I don't really understand why that's... Oh, here we go. Description request. Okay, so now these are looking okay. The end tags. They're not missing any data anymore. However, the name is still not correct here, which is very surprising. Oh, because we have this backwards. We're supposed to append to name if it's not fucked, not if it is fucked. Still only getting 2 bytes in here. So if it's white space or this, oh, then we break. Oops, I just had the fucking case backwards. Oh, dumbass. Dumbass. Okay. So now we have copyright. We seem to be getting the name correct now, right? We have description, this thing. Request, this thing. All right. Big win for us. Big win for us. And so I guess the remaining piece here is going to be attributes, right? Attributes. Yeah. I think everything else seems to be kind of working okay, to be honest. We don't really know if it's conformant in any way, shape, or form, but, you know. And I guess attributes will come in the form of like a key and a value, right? So I guess what we'll do is we will return pointers to our input buffer, right? So I think that what's going to end up happening is we're eventually going to end up like buffering, if this is our XML, like thing key equals v, key equals v, and then like an end tag. Our buffers kind of be like this window, and then for our key value pointers, we can kind of return pointers into this thing as their names, and I think that'll be okay. I think it'll be okay, and we'll just kind of treat this the same way that we treat name, where we'll just like reset our buffer here at the beginning of each loop. So I think we like attributes is going to be an attribute, right? And then we'll have, you know, self attributes dinit self alloc. And then here we'll add attributes clear retaining capacity. And then all we have to do is find the attributes, right? Did we kind of do everything where we touch name? So name's kind of, I guess our token needs some attributes, right? So this is going to be attributes is equal to self attributes items. Seems reasonable. And then I guess now this ends with is not really what we're looking for. I guess it is. We kind of say like, we kind of want like find something along the lines of like self find attribute. I guess like find element token is kind of what we're looking for. And then we're going to be like element token is this, and like switch on element token. And we're going to be like, if we find a attribute, right, we do like self attributes append attribute. Kind of makes sense to me, right? And if we find like element end, we break. Right, that's kind of like hand wavy what I'm expecting to do here. Now I don't know if this is like reasonable in any way, shape, or form. I guess we could also do this as a while self find attribute. We get an attribute here. That seems kind of reasonable. That seems kind of reasonable. And now this will get kind of like encoded in this find attributes function. I guess it should be advance attribute. No, find attribute seems fine. Advance, yeah, sure. Advance attribute. We'll do it this way. So we'll have advance attribute. And he might return an attribute, right? And we are also looking for this like end sequence. So we'll kind of put this here, and we'll then take the token type in here as well, I guess. Okay. So we are looking for white space into something. We don't really know what the spec of an attribute is, but we can check here. It's literally just like name equals value. So equals is white space with an equal sign. Okay. Name is just like characters. Sure. I'm sure that there's some sort of valid ones, but okay. And then attribute value has to be in quotes, it looks like. It's quote followed by, I don't know what the fuck this is. Reference, car ref, entity ref. Oh, I see. So this is like, you could be any of these things, or a reference, I think. Or is this like rejected characters? I actually don't know what this means. Can we look, ask the idiot? I'm sure it's in the spec, but he's gonna know. What does this mean? This part defines how to create, so this thing, inside quotes, you can have any character except for, oh, I see. This is a not at the front. It's a not, so anything but these. So that's kind of regexy, right? That's what, I think that's the regex syntax, and I just forgot it. Right, so anything but these characters. Or a reference, where reference is these special characters. Okay, so we basically look for this. We basically look for this, because we don't really give a shit about the reference right now. Sure. Okay. So I'm actually not 100% convinced here. The up in regex would be start string. Oh, that's a good point. I thought that in regex, in the square brackets, that's how it was though. Right? Like if we do this and we do like ASDF, none of these matches. This matches, A stops matching, S stops matching, D stops matching, F stops matching. So it's the same as regex. Same as regex. Okay. Yeah, okay. I think I get it. So maybe we don't look for the end sequence here. We want to like consume white space, which I guess we can kind of make like a this, which basically does like this stuff here. And this will return the next thing after the white space, I guess. So it's going to be like a while true here. Kind of hand wavy. Which makes like, means that we kind of want to do like this. Which kind of means that now we kind of do like the next advance down at the bottom of this. I guess. I don't know. And then is this the same thing here? Where we have like... No, not really. Not really. So I guess for now, this is ugly. Prototype code, guys. It's prototype code. Kind of do this for now just to avoid the collisions. And then I want to put this stuff back actually so that I just want to see if we broke anything. 169. Okay, I want to make sure that we didn't like break anything. So zig build. Attributes was spelt wrong at 193. And then here he's at 193 because probably in our token we just forgot, we fucked up this. This is supposed to say attribute 102. What the fuck is he mad about? Oh, because advanced whitespace is supposed to return U8. And then this can fail, which means that callers this is right try. Okay, let's just double check this. I think that shouldn't have broken anything. We have a fuck up on poto call again. Which is a little annoying. Oh. Is it like this? Did I forget this? I think I did. I think I did. So we have protocol, name equals protocol, yeah. Copyright, yep. Copyright, yeah, okay, I think we're chilling here. Think we are chilling there a little bit. A little bit. So our attributes now, get status, get add-u, get commit-m smiley face, and when we are finding an attribute then, we just can say self advance white space which will give us the first character. Then we want to continue reading until we find an equal sign. Effectively, right? Because, well, let's see. Where were we? Fuck. I forget what it was. It was like attribute. Here. No, I don't think this was it. I don't think it was right. It was well-formed XML documents have elements who have s-tag content. Oh no, it's more s-tag, which has name s attribute. Here we go. This is what it is. So name is just name cars. That's fine. I'm sure that we can like filter these later. We'll just kind of assume that they have to be like UTF-8 or something. Equals is literally just an equals. I guess we kind of want like both advance to white space and advance while white space, right? I guess it's not really clear. Yeah, sure, fuck it. Advance while white space. Like this. Advance while white space, advance while white space. And advance while white space. Okay, so then we can have advance to white space. Fix me looks a lot like advance while white space. Maybe it doesn't. So I guess what we do here is, I guess technically in buff, I'm not sure. Advance to white space should probably append every single element. And if it finds white space, break. And then he should probably return like the range of elements that put into buff. I guess. I don't know. I'm just kind of spitballing. So here we just return, I guess even here we can just return like the start index. Even then we don't even need to return that, to be honest. we could just say like const name start is equal to self in buff items len -1 because we consumed one character that was not white space. Then we can say advance to white space. Oh, we can't even do that though, because it might be equals. Advance to. I guess we'll, instead of saying advance to white space, we can do advance until and take in like cars here. And we can do like stood mem. There's like some function for this. There's some function for this. Const white space. Return for white space. Other. There's a way to do like look for all of these characters. It's in studmem, I believe. It's like contains any is like kind of what I'm looking for. Index of any here. Index of any is probably what I'm looking for. So here we have any of the values. Yeah. Which isn't really what we want, huh? Because we're kind of consuming one by one. We're not really going through an array. That's kind of what I was thinking of, but that's not the right thing. So we're gonna do something more like I guess we'll say we'll basically just do this. For cars, if B is equal to C, return true. Return. Yeah. That's what we're looking for. Okay, so we advanced until any of these cars. So then we can do a stood ASCII white space as well as the equals sign. I think that makes sense. So now we have like kind of the start and end of the name. And then we advance while white space. And then we should we should say if EQ is not equal to this, we have a fucking problem. So we'll say that this is a malformed attribute. Is plus like concatenate? Yeah. Compile time concatenation of arrays. So it just means that if this is all known at compile time, you basically get like a new chunk of memory that looks the same. And then I guess we do advance until again, where we're looking for white space or this or something. I think that's right. Right? We're looking for either an equals or an end thing. Seems maybe reasonable. And then can we look at Wayland XML again? So it looks like our values have to be in quotes. I forgot. So we advance until a quote. No, I guess we advance white space and const val start is gonna be this, and we're gonna assert. We're gonna say if the value start is not equal to a quote, we have another malformed attribute. Yeah, that's fine. We'll just say malformed attribute again, and we'll maybe stood log error val attribute value does not start with a quote. here we'll say attribute does not have equals. Okay. Okay, that seems reasonable to me. Seems reasonable to me. This needs a fix me to like handle malformed input a little better. But, you know, you could be, we'll ignore for now. Why are you making a parser? Just for fun? Yep, just for fun. A little exercise. A little exercise. And then I think that we will just kind of say val end is going to be, I guess advance until doesn't return anything, right? Yeah, it doesn't. So here, instead of doing val start, we have a self in buff items at self in buff items len -1. Okay. And we can kind of do the same thing here. Except now we're going to advance until a quote. And we'll say, fix me, what if we see an invalid character? So really we should be looking for all of the rejected characters, but we'll just look for a quote instead. And we'll say, I guess there's no checking to do here. So this should give us the attribute value. And here we should say that like const attribute start is equal to the buffered data. I think it ends up being like the last character here. I think. And then attribute end is this. Okay, so we should be able to turn an attribute now that has a name is equal to self in buff items from name start to name end. And the attribute or the value, what do we call this? Fuck. Key val. Which kind of makes me think that name start should be key start. And this should be attribute or val start here as well to val end. There we go. There we go. We're being pretty loose with this, but I think this might work, to be honest. Will you be able to make a parse JSON? I think that would be a different parser is a good answer to that. Okay. So now we're kind of missing the like end case handling, right? Like we're going to keep going forever and ever and ever, but we also kind of have to look for this end sequence as well, which we are not doing. So kind of for all of these things, we kind of want to do like advance until and take in the end sequence here as well, I think. And then here we can say like, if the in buffer was any of these things, we return. But also, if in buff ends with the end sequence, then we have like we also have to return. And I guess here we'll say whether we found something or not. Which kind of makes sense to me. So now we can kind of take in the end sequence here. And basically on these advanced untils, we'll take end sequence like this, and like this. Which means on any of these cases, if we found the end sequence, I guess we'll say false, true the other way. On any of these, we return null if it's true. I think that makes sense. Jesus, this is hard to read. And I guess here it's actually kind of like an error. So we'll say found end sequence before, what am I looking for here? If this is the point after the equals. Yeah, we found end sequence before attribute value. Then we kind of have to do the same thing here. And here we'll say found end sequence before end quote. I guess we don't have to do that here. I'm kind of okay with just kind of like advancing until we see an end quote, because seeing the end sequence in quotations does not count. Now, obviously, we have the problem now where we're not handling escapes, but whatever. Then, is there anywhere else we have to do this? Advance until we see an equals or white space. So if this returns, we will say found end sequence before name end, key end, attribute key end. That feels good enough to me. So what did I just press? Okay, that seems kind of reasonable. So now we will use the end sequence here and take this and put it here. And then we should be good to go. Maybe. Maybe not, but you know. Just need to write try here, probably. 185, this plus plus needs to be a list that it's concatenating with, so we need to put it in quotes. And here he's mad because does advance until fail? Yeah, I see. I see. All right. Log error. This thing needs a little argument thing at the end. There's another one of them here and here. What language are you using here? This is Zig. This is Zig. My current go-to language. Array literal requires address of. That's true. That is true and real. And then 145, we need to append with our allocator. It is an unmanaged array list. All right. Attribute does not have equals. This is probably untrue. It probably does have an equals, and instead we are probably just fucking our shit up. So attribute does not have equals. Can we maybe print the buffer state at this point? What are we looking at here? Version equals, right? So he's just a fucking dumbass. Okay, so what did he get here? It's actually kind of surprising. Stud debug print got eq is this. What have I done wrong here? Got eq, it looks like it's actually white space, which is confusing. That's not what I wanted here at all. Got eq quote. Oh, it's going one too far. It's going one too far. No, wait, that's kind of right. He should be going until... Oh, here he advanced until... He saw the equals here because there's no white space before. We assumed that there would be white space then it equals, which is wrong. So here we need to do if... Oh, this is just stupid. Advance until this thing. Oh yeah, okay, so this is the end of the name, or the end of the key. So now we have to say, This should be -1. Yeah, this should be -1. And then -2 even? Yeah, -1. And then we can say EQ is self in buff items at self in buff items len -1. There we go. Because it consumed the equals. And here, I guess we want to check. This could be like equals or white space. So if EQ is equal to stood ASCII is white space of EQ or white space, we do what we were doing before. Which, did we lose it? No? What the fuck? So if it's white space, then we advance until an equals. Right? If it's white space. Maybe. Yeah, it seems right. Then here, we should say EQ is equal to this. Yeah. Yeah. I guess here we don't have to check it because, yeah, I think that's right. I think it's right. Sure. Let's try that. Got EQ equals, and then attribute value does not start with a quote. Okay, that's good. That's good. Then we've probably fucked up again something here. So this advance until, it goes until one past whatever you wrote here. So can we print in buff again? Swear for you, is this a streaming parser? I don't know. I think so. I'm trying to like go. Yeah, it is a streaming parser. We're trying to be like libxpat. We're trying to be like libxpat. So this is saying attribute does not start with a quotation mark. So we advance until white space. After the equals, which seems kind of stupid. We want to advance until we see. We want to advance while white space. That's what we want to do here. So after we see the equal sign, we want to go forwards while there's white space. We will get back a thing. So we'll call this atter val. I guess we discard the return here. And we check. I guess it's fine. We look at the value. Atter val start byte is equal to this. And if val start byte is not equal to a quote, then we have a problem. So say attribute value does not start with a quote. Return error malformed attribute. Okay. That seems fine to me. We'll see. All right. Wait, that's actually maybe working. It looks like we made it to the end of the file, maybe. Let's see. No, we make it to probably somewhere with an escaped quote would be my guess. Because this is during advance while white space. Be interesting to see where we are here. So this is at 155. I guess what might make sense here is on error to like try to print something out. So we'll go like if lexer next token, we'll do whatever we were doing before. Else we have an error. And we're eventually going to return E for sure, but before we do that, we're going to like try to log the current buffer state. Yeah. So this is E or lexer and buff items. That should tell us kind of how we fucked up. I think we forgot a new line here. Oh, we don't need a new line on errors. I'm an idiot. Okay. Current buffer state has protocol. Oh, on end tags, we are fucking this up. Because okay, so we parse the name. Huh, I'm actually a little confused. So parse the name. Actually, maybe we don't. Hold on, where are we erroring out again? It's in advanced while whitespace. At advanced attribute. Okay. So eventually we try to do this advanced attribute, right? And is it because the name is only triggering on whitespace or this? So as we're doing this, I guess we just need to check at the beginning. Advanced while whitespace is failing because he's hitting end of file before he hits any whites, like at the first character. So we just need to, before we do anything here, check if we have the end sequence here. We need to do like if stud mem ends with. We just need to do this. Attributes are only on open tags. Good point. Good point. Good point. But this at least looks like it's made it to the end. Okay. Maybe. Hold on. Yeah, I think we've made it to the end. We haven't really handled the end case very well. I don't really like that there's description in here. Also, I don't like this. Found end sequence before attribute key end. Because if this happens, then this should be an error. There we go. Okay. So current buffer state is this thing. And we missed a space here, it looks like. Okay. We also write this twice, which doesn't seem right. So this is found end sequence before attribute key end. Okay, hold on. So we look for white space or equals. If, I guess we should do like if this is not equal, which should be the same, but it's fine. And we try advance until the equal. All right, so we're kind of just like fucking this shit off immediately. Let's just double check that in Wayland XML there is supposed to be a space in there. So hold on. This is advance while white space. And then advance until. We must be in here. We must be in here. I guess we don't really know. Let's std debug print buffer state before equal search. This probably makes sense to log it here. Probably. So current buffer state before equal search. Starts with V, right? Okay, so that makes sense. So then he ends up at like, then he's at E for encoding. Then he's at the question mark. So this is triggering something. He's at the question mark, and then he's searching for the equals, but he finds end of thing. Oh, okay. Wait, I think that's fine. I think this is just like a fine case to end up at. Yeah, because it just means that there is no name. Okay. So then we end up. Do you have a malformed input test to check errors are correct? Nope. No, I do not. We're just kind of running it. All of that comes later. We're kind of in like run it mode right now. Okay. First of all, let's got EQ. This can probably actually just go fully away here. So what's happening now? We have a malformed attribute, which unfortunately we lose the backtrace info of, which is a little annoying. I think we can get that back with error trace or something. That's annoying. I would like to like catch this thing and rethrow it without losing the backtracing. I guess we'll just go back to for now doing it this way. I don't care right now. I do not care right now. Okay. So what are we looking at? Oh wait, maybe we did self-advanced attribute. Was that the way we were looking at before? Maybe I was just confused. Maybe I was just confused. Oh yeah, I was. Cool, we don't lose it. I'm just an idiot. So this is at 200. Found end sequence before key attribute key end. Okay. So can we print what equal or white space is here? Equal or white space? It's white space, right? It's white space here. Yeah, we got yeah, it's a new line. So we saw a new line, and then we are looking for protocol name equals Wayland. Very confusing. Very confusing. Can we print like the key here? This should be self in buff items from key start to key end. Like, is it fucked that up somehow? Yeah. That looks really fucked up. So what happened here? Because it advances until the end sequence, pushes the buffer, pushes the byte, checks if it's the end sequence. So like, how is this key ever ending up as close angle break bracket? Doesn't seem right. So this is at start 36 and 37. Right after we see, this is basically second line. Yeah, this is basically second line. So we start at protocol N, which seems reasonable. We're starting at like the beginning of the name search. Then afterwards, he finds name equals Wayland. He seems like he's kind of like correctly digested that, but then somehow ends up like one character past. That's kind of how it's feeling to me. Which I imagine is coming from here. No, because the ends with... Yeah, so at the end here, it's like at this point where we have name equals Wayland, and we haven't parsed this yet, right? So this doesn't trigger. He advances while white's... no, it's not this. Advance while white space will do nothing. So I assume that if we print here, yeah, buffer state before equal search has the end thing in it. Huh, maybe I am confused then. Because then in that case, our end sequence should trigger there. End sequence is this. Unless it's looking for a different end sequence than I'm expecting. No, so it should find it. So let's just kind of check here. If I do this, I assume that won't change anything, but that does change something. So that's really shocking to me. I wouldn't have expected that checking this here, then after a white space advance would be a problem. Oh, so I guess the parser state was... Yeah, I had it right here. The parser state ended with a question or quotation mark here. Then he advanced while white space. It's not white space, and we immediately consume this thing. I see. Which means that these advance while white space things also need to fucking check the end sequence, which is a little annoying. A little annoying, I'm not gonna lie. So I'm just gonna do like a fix me for now, but kind of paste this shit around. So at the front, this is totally fine, but here we're gonna say, actually I think we don't need it here, val start byte. Yeah, it's fine. I don't think that'll come up. Malformed attribute. Okay, so here we miss comments. We miss comments. We do make it a lot farther. And let's just remove these for now, just to see. Can we do like G, delete those, and then it looks like we're fine. Yeah, makes it the end of the file. Makes it the end of the file. So now let's see if we get sane attributes here. So here we do have attributes on the XML thing at the beginning. Maybe we'll print out the name and the attributes. Let's just do that. Let's just do that. So we'll say that we have a name, and we'll print for token attributes. Attribute. We'll say that we have this equals this. Oopsies. Oopsies. Attribute key is equal to attribute val. And then we print a new line. All right, let's see it. Fuck. What am I missing here? Oh, like this. Oops. What the fuck? Unreachable? Wait, what's it complaining about? What the fuck just happened? Okay, so that works fine. And here, if I just try to print this thing, it fucking fails out. Crazy. Write all as e fault. Oh, I've never seen this before. Never seen this. That's kind of crazy. Kind of crazy. Can we look at like what the fuck happened here? Frame, like we're in 18. Token attributes. Maybe I forgot to dupe cure value. I was intentionally not doing that, I thought, but maybe I fucked that up. So here can we do like key pointer? Can we like print this dereference 7 times? Does look kind of fucked up, huh? Does look kind of fucked up. Yeah, these do just look like invalid data. Probably because I'm pointing to the buffer as I'm reallocating it like a fucking dumbass. So here we should have like a difference between like a staging attribute. What up, Svay? What up, what up, what up? Where this is gonna have like a start and end, as will the value. And what we're gonna have to do is this is gonna have to return a staging attribute actually, which is gonna return indexes into this thing. So it's gonna be like key gets key start to key end, and val goes from val start to val end like this. Okay. Then we're gonna have like var staging attributes is gonna be a std array list of staging attribute. Oh fuck me. What did I just do? Here we go. init with self alloc. We defer staging attributes unit. This will probably have to get fixed later, but it's fine. So this goes like this. And then once we have done everything we want to do, this advance, actually, maybe it's this, but that's fine. So the advance, we can't clear the memory of inbuff if our name is pointing to the inbuff, which it is. So it's kind of crazy that the name was working at all either. Oh no, because name is getting appended manually. Sure, whatever. It's fine. I think we can append. We can clear inbuff. I actually don't know if we can. I think that's actually wrong. I think that's wrong. Okay. Fuck. So what do we do instead here? Our attributes just will get duped for now because I don't want to think about it. Just for now, it will be easier that way. So we do self alloc dupe this. It's fine. Does dupe take a type argument? Yeah, it does. And we'll just write fix me. This is definitely doable without reallocation, but it's fine for now. And then we'll just make it so that we leak the memory. It's fine. It's fine. We'll just not DNet this thing. I'm more interested to know if the attributes are right. Okay, so we should see it here, like token is like this. So why are we seeing tokens with nothing interesting? Oh, here we go. Token version equals 1.0, encoding equals UTF. It looks like we're kind of leaking the back quote by mistake. So probably just down here somewhere, this should be -1. Oopsies. And now this looks like it's working. Interface, description, summary core, global object. Oh yeah, that makes sense. Synchrony, asynchronous round trip. Yeah, it looks like it's kind of working. Token, name, registry, type, new ID, interface, double registry, summary, global, registry object. Nice. Nice. All right. XML parser. Maybe kind of working. I think we call it there. We call it there. Pretty happy with that. That took longer than I wanted. What I should have done is I should have cut at 4-ish so that we would have kind of a better we'd have like a longer stream tomorrow, but not the end of the world, not the end of the world. So we've got to the point now where we have kind of walked the whole XML thing. We have successfully extracted the names and the attributes. Obviously, we are going to fall over on all sorts of stuff. But we are pretty close to, at least on this file, being able to do what we did with libxpat. I think that if we fix up this like leading slash on the end tags, I think that we would actually get a workable protocol output here, I think. So maybe we'll come back at this tomorrow and try to do our Wayland code gen with our new shitty XML parser. And then we can always jump into conformance tests and fuzzing, as King Julian is saying. So if you want to see that, we'll be back at it tomorrow. Thank you for watching. If you like what we saw, we stream most days at around 12:30 Pacific time to 4 o'clock Pacific time. It is 5 o'clock Pacific time now. We've done this accidental trend of streaming for too long, which is bad for YouTube because I don't think that people really want to watch 3-hour YouTube VODs. 2 hours is kind of where I personally start to get bored. So I would like to keep it around there, but sometimes we mess up and that's okay. If you want to see more, there is a YouTube link in the Twitch description, and we have playlists for all the things that we've been working on. Right now, we are actually kind of more in this long-term project of trying to basically write a virtual GPU like both in terms of like implementation and GPU driver and user space driver. But we're taking a couple day break from that to work on this because my head is starting to just like, I'm tired of banging my head in the wall on the GPU stuff. I think there's like lots more to do there, but I just need a very, very, very slight break. So we'll be back at that in a few days, so swing back by if you want to check that out. If you're on YouTube, there's a Twitch link in the YouTube description. Swing by, say hi. Like, subscribe, Twitch Prime, and I think that's all we usually plug. Oh, there's happy hour segment and main stream segment. So happy hour goes 12:30 to 2, mainstream goes 2 to later. Happy hour is kind of like more background stuff generally. So like reading or code cleanup or unit testing or stuff like that. Mainstream is usually more like new feature type stuff. So if you want to see the happy hour streams and you're watching VODs, those are behind the membership button or on Patreon. I think that's all we usually plug. Goodbye, YouTube and Twitch. Let's find someone to raid.